Today we are beginning our review of all of the FRQ questions that will be on the AP exam. So these questions are going to be, it's part 2, it's section 2 of the AP exam. It is worth 3/8 of your score, so it's almost worth half of your score. All right, be sure to write clearly and legibly. Cross out any errors you make. Erased or crossed out work will not be scored. My preference for you would be to cross out rather than erase. Erasing takes more time than crossing out, and you might find that you need some more time. So just exit out instead of erasing. Manage your time carefully. On average, 15 minutes per question, on average. Some questions you'll be able to do quicker, some questions it will take you longer, okay? There are 4 free response questions, but they're separated into 2 and 2. So you'll have 30 minutes on one section and 30 minutes on the other. You must show all of your work. Your work will be scored on correctness and completeness, okay? During part A, you can only work on questions 1 and 2. Those are with a calculator. Okay. You are expected to use your graphing calculator for tasks such as graphing, using tables, evaluating functions, using your stat feature to get models, things like that. Okay. For part A, your calculator must be in radian mode. I will remind you of that before you walk down there that day, but it has to be in radian mode. Avoid any rounding errors. Okay? All decimal approximations must be accurate to 3 places after the decimal point. At least 3. You can give more, but not fewer. Okay? You don't round until the very end of your work. Use the full answer until you get to the very end of your problem, of the question. Okay, for part A, it is helpful to use your graphing calculator to store information, such as those computed values of constants that you're working with. Okay, all right, let's see, during part B, questions 3 and 4, no calculator is allowed. You may continue to work on questions 1 and 2, but you cannot use your calculator anymore. Unless otherwise specified, the domain is assumed to be the set of real numbers for which the function is a real number. Okay? All right. So topic number 1. Today we're doing topic number 1. This is called function concepts. It is with a calculator. You will be given at least 2 functions. One may be given as a graph or a table. The other is likely going to be an equation of the function. A 3rd or 4th function might be introduced in the problem. You're going to be asked to do several things with these functions. Best advice, just do what it tells you to do, and don't assume that you know what it's going to tell you to do. You do what it tells you to do. Part A. Okay. In part A, a 3rd function will likely be defined as this, and you're going to be asked to find a value of h. So they'll give you like a graph of g and the equation for f, or maybe the equation for g and a table of values for f, whatever. G is the composition, h is the composition, find a value of h. Okay? Use good notation, show your work, show what you are doing. Don't be messy. Okay, in part 2 of section A, you can be asked a variety of things. Find a value of the inverse of f. Find the value of x where f is some number. Determine where f is greater than or less than something else. It can just be anything. Recall that a function has an inverse function, that means it's invertible, if each input value produces one unique output value. That means that the function passes not only the vertical line test, but it also passes the horizontal line test. However, do not state as a reason that the function passes the horizontal line test. You have to describe the horizontal line test. You have to say, every input value produces one unique output value. That will get you the point. Okay? Part B. Alright, be prepared to answer questions about the function defined by an equation. Whichever one is defined by an equation, prepare to answer questions about it. Determine values of the function, values of x, that the function has a particular value, what happens as x is going to infinity or negative infinity, things like that. Part C, if you have a table of values for a function, be prepared to do some things with those values. Determine a best fit curve for it using the input and output values of the function. Find the average rate of change, things like that. And then just random things. Just do what it says to do. Don't be rattled. Get every point that you can get. We're going to do a couple of these in your set of problems there. We're going to start with the very first problem. We're going to do this one. Let f be an increasing function defined for x is greater than or equal to 0. The table gives values of f at selected values of x. The function g is given by this. So this is with a calculator. So what do you think I'm going to be doing with this? I'm going to immediately get rid of what's here. Immediately I'm going to put that in for y1. So I'm going to pull up my fraction template. The fraction template is under F1. So second F1 here, not second F1, alpha F1. That very first one, that will give you the fraction template. So x to the third minus 14x minus 27 is the numerator, and then the denominator is x plus 2. Okay? So that's stored in for y1. Got that in there. Part A, h is given as g of f of x. Find the value of h of 5 as a decimal, or indicate that it is not defined. So part A, there will be a one box just for part A on your paper, and there will be plenty of room. On mine, I try to conserve space, so I didn't give us all that much room, but just know that you will have plenty of room on the test. Okay, we want h of 5. We need to say what we're doing. That means g of f of 5. But f of 5 is 34. So that is equal to g of 34. And that is equal to, I get to use my calculator. G is right there. I'm going to go to my home screen, so second quit. Y1, remember all the Y1, Y2, Y3, all of them are under F4. So alpha F4, Y1 at 34. Now, it gave it to me as a fraction. I don't want a fraction, I want a decimal. So I'm going to go up to it, pull it down, go behind either the numerator or the denominator, and put a decimal point. That's the easiest way that I know of to get this to be a decimal. The other way that we could have done that, you guys, is to, when we were typing in y1 at 34, is to put a decimal right there. And that also would have given it to us in decimal form rather than fraction form. So our final answer has to be correct to at least 3 digits after the decimal point. You'll see on my paper I always write a 4th digit because I want to know whether if you do round this value, if you should have rounded it, or if you have to have left it alone. Remember, you can either truncate or round it if the next digit is a 5 or higher. Okay? the easiest thing to do is just to truncate, just to write what you see. First three you see works for me and AP. Okay, that was part 1 of part A. That means that we just got a point. One of the 6 possible points for this problem. Part 2 says to find the value of f inverse of 4. F inverse of 4. So let's think about this. That means on F, so kids get these two confused. What would be the point? What would be the point? So there are 2 points. There's a point when x is 3 and y is 4. That means f is 4. And there's a point when x is 4 and y is 17, which means f is 17. We want the one, for this problem, we want the one whose, because this is f inverse, not f, it's f inverse. The point on f would be 3, 4. The point on f inverse would be 4, 3, because you reverse the x's and the y's when you're getting the inverse. So f inverse of 4 is equal to 3, because f of 3 is 4. Okay? Now that was just thinking. That was my scratch work up here. Down on my paper, all I'm going to say is f inverse of 4 is equal to 3. That's all they wanted. They said find the value of f inverse of 4. I found the value of f inverse of 4. You don't need to say anything more. And my best advice is to not say anything more. There's 2 points that we just earned. On to part B. Find all the values of x as decimal approximations for which g equals 3. G equals 3. Or indicate that there are no such values. Well, g is equal to 3. G is stored in right here. We want for it to equal 3. So in for y2, I'm going to put 3, and I'm going to find out where these intersect. Now, don't know a whole lot about this curve, so I'm going to do zoom 4. That's my nice window. It usually is where I start. Well, I'm thinking that I am missing something here because I'm only seeing a very little part of that curve, right? So I'm going to zoom out. I'm going to zoom out. So zoom 3, and you hit enter. Oh, there is something definitely more going on in the curve. There's definitely something going more in the curve. However, it only hits 3 once right there. So I'm going to say, we're going to find the point of intersection, go to calc, intersect. What is my first curve? Hit enter on the first curve. What is my second curve? Hit enter on the second curve. What is the guess? Since there's only one point of intersection, I'm just going to push enter right here. You know you're done when it says the word intersection. So g of x is equal to 3 at x is equal to 4.875. You have to give at least 3 values after the decimal point. So that's all they wanted for part 1 of part B. Part 2, determine the end behavior of g as x decreases without bound. As x decreases without bound. So what's going on as x decreases without bound, and we're supposed to use mathematical limit notation. So the limit as x approaches negative infinity, because we're decreasing without bound, of g. We can use our graph here. As x, if we just hit trace, let's hit trace, and I'm gonna arrow to the left because I want x to decrease. So x is decreasing. It looks right here, it looks like x is going, like the curve is going way down, right? Right now, x is negative 1.6 and y is negative 1087. But if I go one digit over, that's where x is negative 2. That would be our vertical asymptote, right? That's our vertical asymptote. If I keep going to the left, now it's my y value, 903. 0.1 difference, 903. Go over again. It's now here. These are in decimals. These are in fractions. I really don't want them to be in fractions. I'm going to go into any digit here and put a decimal point. I'm going to put a decimal point behind that too. That way when I'm tracing, trace, it'll be in decimals, not, that's better. Okay, decimals, not fractions. So I'm going to go over. I want x to decrease without bound. As x is decreasing without bound, look what happens to the y's. What's happening to the y's? Y is getting very, very large. Is it going to keep getting large? Yes, it will. It will keep getting very large. So as x goes to negative infinity, g is going to infinity. So far we have 4 of the 6 possible points. Let's go on to part C. Use the table of values use the table of values of f to determine if f is best modeled by a linear, quadratic, exponential, or logarithmic function. Okay. Here's f. How would we determine if it was linear or quadratic? If it was linear, the differences between these, because x is equidistant, these values are equidistant from each other, these values should be also equidistant from each other if it's linear, right? To get from negative 10 to negative 5, we would add 5. Negative 5 to positive 4, we would add 9. 4 to 17, we would add 13. 17 to 34, we would add 17. So this is not linear. Is it quadratic? 5 to 9, we would add 4. 9 to 13, add 4. 13 to 17, add 4. It's quadratic. So in part 1 here, we just want to write the answer. We just want to say quadratic. In part 2, we say y. Okay? In part 2. Part 1 is just the answer. Part 2 is y. Okay. So we're going to say something about the second differences. Okay, but we do need to say the x values are equidistant from each other. So the x values are equidistant from each other. The second differences are the same. So f is quadratic. So they just want you to say in words what you did. Okay? Alrighty, 6 points. These I don't think are too bad. It's easy to get a bunch of points on these. Okay, let's go now to the last question. This was the question from the 2024 exam. Okay, and you can see what the global average was. The global average was the average student got 3 of the 6 possible points on this. That should tell you that you do not have to get all 6 points on these in order to do well. So don't stress out if you don't know how to do a part or two. Just keep on going. Do what you can and get every point that you can. All right. The figure shows the graph of f on this domain. The points -3, 1, -3, 1, 0, 1, and 3, 1 are on the graph of f. The function g is given by this. Okay, so in my calculator, I'm going to go put g in. So I'll clear this out, clear that, clear, clear, clear. 2.916 times 0.7 to the x. Make sure you get that in there right. If you don't, all of your answers are going to be wrong. Not all of them, because some of them only involve f. But, okay, part one of part A. Okay, h is g of f of x. Find h of 3. So part A, h of 3 is g of f of 3. F of 3 is 1. G of 1 is, let's go to our calculator, go to our home screen, G of 1, so y1 at 1. 2.041. Okay, so, and we are giving at least 3 values after the decimal point, right? Okay, part 2. Find all the values of x for which f is equal to 1. F is equal to 1. Well, f is equal to 1 at -3, 0, and 3, right? So we're going to say that. F of x is equal to 1 at x equals -3, 0, and 3. So far, we got 2 points. We're almost to the global average, and I feel like we've done very little. Part B. Find all the values of x as decimal approximations for which g is equal to 2. So now we're going to g, and we want that to equal 2. So let's go graph g. So remember, our g is stored in for y1, and whenever you want to start a graph, zoom 4 is your friend. Zoom 4 is your friend. Okay. Does that look like a good representation of this, or do I need to expand the window? This is an exponential function, right? With the base less than 1, so it's going to be a decreasing, it's going to be a decay function, right? This is about all I need, right? So here I want for g to be 2, so I'm going to go to y1, go to another y, let another y be 2, because they told me to. There's one value where that's true. Second, calc, intersect, enter, enter, enter. You know you're done when you see the word intersection. You are not there until you see the word intersection. So for part B, I'm going to say g of x is equal to 3 at x is equal to 1.0571. At least 3 numbers after the decimal point must be accurate. Part 2 of part B, determine the end behavior as of g as x decreases without bounds. So we're finding the limit as x goes to -infinity of g of x. Okay, so what happens? I'm going to trace. It's tracing y1, that's what I want. I'm going to go, we want x to decrease. What happens to the y coordinate as x decreases? What is y doing? What do we know every exponential function does as y decreases? As x decreases. it's going to go up. We can verify that on a window. It's a slow decrease, but it's a slow increase, but it will be increasing. There we go. That's a little bit better. Okay, so it's going to positive infinity again. Okay. Alrighty, part C. Determine if f has an inverse function. Does f have an inverse function? So part 1 is just yes or no. Yes, f has an inverse function, or no, f does not have an inverse function. Okay? So, does f have an inverse function? So for f to have an inverse, every input must give one unique output, an output that is not repeated. In other words, no horizontal line can pass through more than one point, and we know this one does. So in part C, don't just say yes. I said you can just say yes or no. Don't just say yes or no. It says determine if f has an inverse function. If you say no, you're saying no, I'm not going to determine if f has an inverse function. I want you to say, they need you to say, f has or f does not have an inverse function. F does not have an inverse function. And part 2 says, give the reason. Well, as long as we can find 2 points that have the same y value, we have shown it. So I'm just going to use 2 points. I'm going to say f of 0 is 1 and f of 3 is 1. And honestly, that's all I really have to say there. So f cannot have an inverse function. It is not invertible. So here's where you do not want to say it does not pass the horizontal line test. You have to give a specific reason. Okay? This, I could have done it differently. I could have said something like, the input values of x do not produce unique y values all the time, but this is a specific example of when they produce the same y value. This is preferred. Okay? Alrighty. So that's it for this type of problem. Practice, practice.